In this video, we're going to have a look at creating vase mode spars as an alternative to a gyroid infill. Here are some workflows to convert some RC STLs that you might want to play with. I like gyroid infills just about as much as anybody, but when we get to the point of using lightweight PLA, there's some problems. All that cruft inside, well, that's weight, and it's just not elegant. And are there alternatives? Here's a print for an end of a wing. The one on the right is the official 6% gyroid infill. On the left is one that I took the STL and converted it to have internal spars, and it prints in vase mode. Not only does it print faster, it weighs actually a couple of grams less. Both prints seem to have the same stiffness, and we do this by creating some bodies we can then subtract from the STL in a particular way. A couple of years ago, when I was first getting into using lightweight PLA, I was working on Clark Y ribs for a project. I thought, well, there's a lot of ribs in here. What would happen if I tried to make them less weight? There's this new stuff called lightweight PLA. Maybe that would work. I see lots of projects around which advertising themselves as being vase printable. Gradually, I figured out the rule set. Have a look at that YouTube to see if you want to find out where the idea came from. All of the workflows that I'm going to present start from the same basic task of importing an STL, converting it to a body that can be edited, and then getting that body relocated to the origin of the CAD model. A lot is covered in this YouTube video, which I suggest you watch before you carry on. The next video to watch is the one about using slice apart to create matching ribs. Spars is going to be a variation on this for many of the steps. Because the original STLs differ, there might be one of several different workflows which is best for you. Here's an overview of the workflows that we're going to be covering. First you take the STL, convert it to a solid, move it to the origin, and then optionally make a refined copy and then a second copy of the solid. We also need to set up a bounding box that's slightly bigger than the STL, and we want to move that and resize it so that it fits around the mesh. And then we go to this step B, we choose a face, and then we have three choices, one of which is going to be, I'll call the ISO mesh, to where we create lines on that face, extrude them, and then turn them into rectangles, which we can then use the cut apart and shift on. For some projects we need more flexibility, and one option is to take the face that we've highlighted, make a sketch on it, and draw lines at the spar positions that we would like, and then extrude that and then proceed. The other variant is basically to set up very thin rectangular bodies at the spar positions, join them together, and then cut them apart from the STL. At the end of those three possible variants, we're going to take the spars that we've created and fuse them together, shift them just slightly, and then cut them away from the STL solid. Here we take a side view of the box and the mesh to ensure that we have proper clearance. Our next step is to highlight that wide face, change from the part workbench to the curves workbench, select the ISO mesh, and set the mesh density to get an initial estimate of where the cut lines are going to be. At this point, it's good to double check things. For example, if I rotate the view slightly, I can see that one of the potential cut lines is going to interfere with one of the features within the STL. That probably will come back and haunt me later on. And the next issue is, well, I've made quite a few potential cut lines there. If I preview that, maybe that's a higher density of spars than I'm really looking for. I also might want to go back to the bounding box and shift it to the side a little bit. They might be better placed to avoid the particular features that are going to cause a complication. Another handy hint is to create visual blocks at the locations of those critical features that you want to avoid, so that it's really clear when you look at the model from the side that in fact you know what you're trying to avoid. While we're looking at this image, it's actually an example of the second method, where we want to go back to the highlighted face and actually create a sketch on it, and on that draw some vertical lines in the places that we would like the spars to show up. And then when we rotate around and try extruding these lines, we'll get a preview of where, and that might work out quite well for you. The final option is to create a series of very thin rectangular bodies. When we cut those apart, we should be able to use them to cut away from our original solid mesh. Sometimes that works well, sometimes it can be a problem. Whichever method we chose, we now get to the bit of magic. We've got two bodies that we will be working with. One is the extrusion, in our case, the slices of that are going to be the spars itself. And we are going to cut it apart with the mesh solid, which is really just a shell. And we're going to get out of that an inner portion, which is actually the spar, and an outer portion that we can just throw away. If you have not already done so, make a union of the spars themselves. And then what we would like to do is go in and shift them just slightly, about 0.4 millimeters, so that they then sit proud of the mesh. This then allows the slicer to be coerced into creating our vase mode spars. Our last task is to use the Boolean function to first click on the copy of the solid mesh that we created very early on in the process, and then control click on the thing that we want to cut away, which is the spars. Here is a session creating spars by way of the ISO mesh option. So here's our model to start with our bounding box, the two slots to give us a clue where things are, and then the solid for the wing. Let's have a look at the bounding box, turn it just slightly, and highlight the face. And then we switch from the part workbench over to curves, and in the curves we find the ISO curve option. We then go and adjust the ISO curve values, U and V, in this case taking the U down to 0, and the V up to 9. Now let's have a look to see how we're doing. That's very close there. Let's go back to the bounding box and find its placement and tweak the Y slightly. Then we go back to the ISO curve, have a look, and that's got that all right, but it's awfully close on that right feature. So let's relax that just a bit. Okay, go back to the curve. Okay, that looks much clearer of the features. And then we go from the curves to part workbench. And then we're going to extrude those ISO curves, adjust it so we can see. We don't want symmetrical. We want to extrude about 60 millimeters, but we want to go in the -X direction. And we'll apply that. Yes, that's what we want. And we have a look down. Yes, we've cleared those features. And we say, OK. So at this point, I've actually got two extrude bodies. I really only need the first one. So the extrudes are what I will want to cut to use the slice apart with. And I'm going to slice it apart with the wing. Now, before I go and do that, it's a really good idea to save at this point. Sometimes this works, sometimes it doesn't, sometimes it hangs. It's good to have a place to come back to restart if there's going to be a problem. So I control click on the wing and I go into part to the split, slice apart. Now, if it's working, yes, we get a response back. We see exploded slice. Lots of different slices there. For example, slice 0, we don't need that anymore. Slice 1 is the outer part, slice 2 is the spar, so we get rid of 1. Slice 3 we can get rid of. Slice 4 we keep. Slice 5 we can get rid of. Whoops, we made a mistake. Let's go back. We want 13 deleted. And we can delete 15. Okay. Let's hide the bounding. Now, what I want to do is go into each of these slices and I want to tweak it. I need to offset them just slightly from their initial position. So I need to move them in the X. In this case, I'm going to do a 0.5 millimeter. This gives me a little gap inside, makes it protrude on the bottom face of the wing, so I'll get a smooth top portion of the wing. And I carry on and do this for the other spars. And now I highlight all of them, and I want to then extrude them all. Now, the extrusion I usually use is 0.2 millimeters, so it's a very thin body. Just making sure that, yes, those are the slices I've got highlighted that it'll apply to. So I say apply. And now I have some solid bodies. And these are now shown as extrude 1, 2, 3, 4, 5, 6, 7. I highlight the extruded bodies, and I want to go in and make a union of them. Let's just scroll over. Yes, there's the union button in FreeCAD. Okay, and then I'll rename that. Give me a clue, spars to cut. Okay, so that's my solid that I want to cut from. I'll just do a quick preview here before I do the Boolean cut. So they're all sitting slightly proud. So I want to cut the spars from the wing, so I use the cut function. Now, this can take a while. And what we end up with is this kind of view. So there's my cut. Let's hide the two slots. There we go. Okay, now cut. What I'd like to do is export the cut as an STL. So export. There's the name. I'll save that. And then I'll go and start the Prusa slicer. In the Prusa slicer, I will then go and find that STL I just created and import it. And it comes in, and I can see, if I zoom in, yes, it's got the little telltale lines on that surface. But just to make sure, I need to change the infill to 0. And I'm going to go to one perimeter and cut down the layers on the top and the bottom slightly. Then I'll go back and I'll ask to slice this. And if I then go and drag down through, I can see, in fact, that I do have the spars created. I've got my little tabs at the bottom. So this has been successful. We just, although there's a little bit of gap there with lightweight PLA, it is going to fill in and form a proper spar.